Class example 2.43 is a richer example of class example 2.41, and perhaps one of the more fun problems in polynomials. Here we're given a graph. We're told that the zeros are integer values, and we're asked to state the minimum degree of the function and determine the factored form equation of minimum degree. We know that each x-intercept corresponds to a factor in the equation. Here, our intercepts of -2, 1, and 4 correspond to factors of x plus 2, x minus 1, and x minus 4. As discussed earlier, when a graph bounces off a certain x-intercept, we know that its multiplicity is even. Here, because we are working with an equation of minimum degree, we will choose 2 as that multiplicity. This is represented by the exponent of 2 on the factor of x minus 4. In class example 2.41, we would have written this as p of x equals 1 times x plus 2 times x minus 1 times x minus 4 squared. However, we do not want to assume that there's been no vertical stretch, because the vertical stretch will not change the x-intercepts, which means that there are actually an infinite number of different graphs that have exactly the same x-intercepts as the one shown here. The only thing, therefore, that will distinguish them is the a value, that leading coefficient which represents the vertical stretch. In order to determine the value of a, we will use any point on the graph that is not an x-intercept. We can't use the x-intercepts because that would cause the right side of our equation to be 0, meaning we would not be able to isolate a. Let's use the given point of 0 and -16. By replacing x with 0 and y with -16, we're able to isolate the value of a as being 1/2. This represents the coefficient to our polynomial. It's always a good idea to verify our work graphically using our calculator. Here, by typing in as y1, we can see that the x-intercepts correspond, as does the y-intercept. We will see that the steps in part B are almost identical to those of part A. We'll start by identifying the x-intercepts and writing the corresponding factor of each one. Here, we see that the intercept at -1 gives a factor of x plus 1. Because this is a point of inflection, a squiggle as it crosses the x-axis, we will put a degree of 3. Remember, we can't actually tell if it's 3, 5, or 7, or a greater odd number, but the question told us of minimum degree. The x-intercept of +2 gives us a factor of x minus 2, and because it bounces, we will put this as a multiplicity of 2. Note, when we write our polynomial function, we state p of x is equal to a times the two factors. Again, we do not know what the vertical stretch is, so we're going to use a point from our graph to determine it. It's worth noting that in both of these last examples, we've used the y-intercept. It is not necessary to use the y-intercept. We could have used any point that was given, so long as it was not an x-intercept. After determining your a value, it's always a good idea to check. But one thing you can check without your calculator is whether or not the positive or negative sign in front of the leading coefficient is correct. Here we see our graph is rising to the right, so we were expecting our a value to be positive. Typing the full function into our calculator, we can see that both the x-intercepts and the y-intercept are also correct.